Alright, let's look at misuses of statistics. A quote that you may have heard: there are three kinds of lies: lies, damned lies, and statistics. And I've seen this attributed to various historical figures, and I'm not going to make any claims that it's one over another. You may have heard that the data doesn't lie. And while I believe that's true, sometimes people do. While the science of statistics can be used to make sense of data and to make inferences with the data about the greater populations, it can also be used to coerce using intentionally biased sampling techniques and or improper representation of the collected data. So, let's imagine two groups performing a survey on Mitch McConnell's approval rating. One group polls the Lexington Republican Party. The other group polls the Lexington Democratic Party. For some reason, the outcomes are different. I wonder why. Do you think that those samples were unbiased? Somehow I don't think that either one was unbiased. We often hear things like 79% of all Americans believe this or that. When we hear anything like that, we should always ask, who performed the survey? Do they have a stake in the survey coming out one way or the other? Who was surveyed and how were they selected? In other words, was the sample biased? Was the sample unbiased? How many were surveyed? If I poll 3 people in my house, that's not really enough to get a feeling for how Lexingtonians feel about a certain issue. And finally, how sure are we of the results? And that comes to play in a confidence interval. You might see a margin of error, especially on political polls, margin of error 3%. And so when we see that 2 people are within 3 points of each other and the margin of error is 5 points, well, that means there's basically no meaning to that survey because it's a draw. Ambiguous words. Statistics can also be presented using ambiguous words like average, which we will see in 13.4 or later in this module, can mean many different things. We also throw around words like largest. Right now, big thing going on is that AT&T and Verizon both claim to have the largest 4G networks. Is one of them lying? Are they both lying? Are they both telling the truth? Well, it could be in the way they select what is largest. One might be counting the number of customers while the other's counting towers, or counting towers versus counting markets. You got to find out all the information. This is where statistics can lead you with ambiguous words. Also, Duracell and Eveready both claim to have the longest lasting batteries. Who's right? Have you ever noticed that Duracell tends to have AA batteries in their commercials and Eveready has D batteries? Maybe Eveready's D batteries last longer and Duracell's AAA last longer. Who knows? Another abuse comes in the form of selective statistics. Over 1 million people switched to Company X last quarter, but they disregard the statement that, or the fact that 3 million people dropped Company X and went to another company. It's easy to give a sliver of the picture and only give what you want to show. Those are selective statistics. Another form of misleading statistics is to guide the public toward illogical conclusions. You could say, Our paper towels are heavier, so they are more absorbent. Well, does it really follow that a rock is more absorbent than a sponge? Weight might not be the only contributing factor. Finally, the presentation of data is often imprecise, whether intentionally or unintentionally. In your notes, we have a number of graphics. For example, looking at these two stocks, it's obvious to me that stock B is much better, right? I'd be jumping right onto that one. But in reality, they show the same information. What we've done is taken this zone right here and blown it up. These two graphs show the same information, but if company B is trying to push their stock, this could be company A's stock, where they have the exact same information, it makes it look like company B is better. Similarly, looking at this graphic, well, look at this big huge jump. That's the same as this jump. Watch for scale. In fact, you'll see later when we're talking about histograms, we're not going to allow any of these little jumps and scales like that. We're going to start our scales at 0. And along that line, this is the same situation, except it's the horizontal scale that's been chopped. Looking at this one, another thing that'll get you is area. This says $1. This is $2. The box is 4 times as big as this box, the $2 box is. They doubled the width, but they also doubled the height, which gives us 4 times the area. Make sure that the graph is showing what it should show. In your notes, there's a picture of America in 2000 and in 2050. If you look closely, the population of 275 million to 394 million, that's a 43% increase in population. Okay, that's significant. But if you look at the circles, they have a 125% increase in area. So the circle is on the right is much too large when comparing this data. What about this one over here? Why people surf the web? If we look at the percentages, we see, okay, this says 49 and about half that's 24. So, you know, with respect to each other, they're about the same dimension. But look at this, 49 and 42, that's 91%. So 91% is taking up half this circle. This circle doesn't have 100%, it's got 180%. This is not an appropriate way of displaying this, because some people use email and do research. Some people are counted twice in this graphic.